the first question, that's okay, Lloyd, it's okay. So the first question is pretty simple. It just uses a simple application of the associative property. So did anyone solve this question? Okay, I think 3 people told me that they got the answer E. Okay, Sean, you got E. Would you like to share with us how you got your answer? You can feel free to unmute. Or you could type your answer if you would like to. Hello? Okay, that's okay. Okay, so again, this is a, oh, hello, Kimmy, go ahead.
Can I? Oh.
Yeah, sure, go ahead. You can annotate on the board too if you want.
It's really easy. It's just this. Oh, wrong color. It's just this and this together, and then 11 and 19, and then 21 and 29, until you got 10, 30, 50, 70, and 90. And then 10 and 90 make 100, 30 and 70 make 100, and then 50 is just alone, so it becomes 100 plus 50.
Right, that's precisely the process. So just to rephrase that a bit, basically, if you learned the associative property of addition, you would know that when you have a string of added numbers, you can arbitrarily change the order of the parentheses and still get the same answer. So what that means is you can add 1 and 49 together. You can add 11 and 39 together. You can add 21 and 29 together. You can add 31 and 19 together. And you can add 41 and 9 together. And all of these would give you 50. So you have 5 copies of 50, which would give you 250. Pretty simple. Are there any questions on this one?
Who made this question?
It's from one of the, okay, so all of the questions we're doing are from the past AMC tests. So I guess you could say the Mathematical Association of America.
Because whoever made this is extremely dumb. Why would they put 249? We know it's definitely not going to be that. Or 199.
All right, okay. So did anyone solve question 2? Okay, D. Jasper, would you like to share your thought process?
Oh, well, I don't know how to explain this. Well, I saw the denominators, and put them into decimals, and then I just got 0.246.
Okay, that's good. Here, I'll help you out a bit. So basically what Jasper is saying that he changed all the fractions to decimals. So 2/10 would give you 0.2, right? And then 4/100 is basically 0.04. And then 6/1000 is 0.006. So when you add these all up, you get 0.246, which is D. Another very simple warm-up problem.
8.
Does anyone have any questions on this one? Nope. Okay.
Can you do 2/1000 plus 200 over 1,000 plus 40 over 1,000 plus 6 over 1,000?
Definitely another valid method. So what you could also do is you can make them have a common denominator, right? So you'll turn the 2 over 10 to 200 over 1,000. And you'll change the 4 over 100 to 40 over 1,000. And the 6 over 1,000 will stay at 6 over 1,000. Then when you add these up, you get 246 over 1,000, which is equivalent to 0.246. So yes, that's another way to do this. Any questions? Okay. All right, this one is so easy that I'm not gonna ask for any solutions, but just let me know what answer you got. A. Okay, yeah, this one should be pretty obvious, right? 0.99 is kind of obviously greater than every number. Unless anyone needs help on this one, I'm gonna skip ahead. Nope. All right. Okay, question 4. Here we go. Okay, which of the following numbers is closest to 401 over 0.205? What did we get for this one? Sean says E. Zion says E. Kimmy says B. Okay. So we have some conflicting answers here. Jasper says E. Okay. Zion, would you like to explain how you got E?
Well, first I just hold on.
It's okay, take your time.
Yeah. So I estimated to 0.2 and 400. And since you're dividing 400 by 0.2, it would basically be like multiplication. And I estimated that it would be around like 2,000. It would be closer to 2,000 than 200.
Precisely, that's correct. Kimmy, yes?
But why? It's
Okay,
point
so
205. Doesn't that mean it round to 200 and then 400? So 200, 400, 200 times 5 equals 1,000. And then 400 times 5 equals 2,000, which makes 2.
no, here, okay. Here, I'll explain how we round this problem. So basically, you want to look at the numerator and denominator separately, right? You want to round 401 to the closest nice number. And I think we would all agree that 401 would round to 400, right? It's a really nice number that's really close to it. And to round the denominator, we would round it to 0.2, right? Because it's a really nice number that's really close to 0.205. So what does it mean when we divide by 0.2? One way you could look at this is to say that, oh, well, 0.2 is 1/5, right? So if you divide 400 by 1/5, that's basically saying 400 times 5. And that would give you 2,000, right? Another way to do this would to say, okay, I'm going to divide 400 by 2 first to give me 200. But since the actual division is by 0.2, I actually have to divide by one less factor of 10. So I got to amend the 0 at the end, which once again gives you E. So the answer is E. Does that make sense, Kimmy? Does anyone else have any questions on this one? Okay. It's okay, you'll get better with practice. All right, let's take a look at the next question. All right, so for question 5, it's really just following the orders of operations. And Kimmy says he got C. Do we have any other answers or? Okay, Jasper says D. Okay, so C or D. Here, I'll just work it out for us, okay? So in case you haven't learned the order of operations, this is the rule you want to follow. PIMDAs. Here, the P stands for parentheses. The E stands for exponents. The M stands for multiplication, D for division, A for addition, S for subtraction. This is the rule you want to follow in general. So if we just follow this rule here, you will have -15 plus 9 times 2, right? Because we want to have the parentheses first. So that gives you -15 plus 18. Note how we multiply the numbers together first because M comes before D. I mean, M comes before A and S, right? And then finally, you add these together to give you 3. So the answer is actually 3 in this case. Is this confusing to anyone? Are there any questions? Going once, going twice, going 3 times. Why don't you switch it? What are we switching?
I mean, like, why don't you like switch from negative? Like, there's a negative right here. Why don't you like switch these around so that it's
Oh, so like 18
positive?
minus 15?
Yes. So it would be like, no, I mean like switch these around.
Oh, well, I mean, you can't really do that, right? Because
Why?
fundamentally, the negative sign in front of the 15 is saying that you're taking away 15, right? So you can't just say, I'm going to put a plus sign in front of it and now add 15, right? Because, I mean, you can switch the plus 18 and minus 15 around. You can say 18 minus 15, and that's the same thing. But you can't, like, inherently change what the operations
Oh.
are saying, right? Because,
Okay.
yeah, okay.
Fine. I didn't actually study for my algebra test.
That's okay. It's okay. All right, let's look at question 6. If the markings on the number line are equally spaced, what is the number y? Do we have an answer for this one? I have an E, a C. Okay, Kimmy, do you want to explain your thought process?
Yeah, it's what I did was kind of like it's kind of obvious. It's more like because every spacing is equal, that means 20 divided by how many spacings. So because there's here's 1, 2, 3, 4, 5. There's 5 spacings, which means 20 divided by 5 which equals 4, which means each of these spacings are 4. So 4 times how many spacings? So 1, 2, 3. So 4 times 3. No, 4 times. Wait, no. Oh, I'm confused. Oh no, 4 times 3 is
You're right, yeah.
4
You're
times
right.
3 is 12, which you get the answer.
That's precisely right. I'm not even gonna elaborate on it anymore. Does anyone have any questions about this one? No? All right. Question 7. If the value of 20 quarters and 10 dimes equals the value of 10 quarters and n dimes, then n equals what? Okay, I'm seeing a lot of D's here. Okay. Uh-oh. Okay, so I think everyone is agreeing that the answer is D. Would anyone like to explain how they got this answer? Maybe someone besides Kimmy?
Yeah, I don't want to explain anymore. Too complicated.
Sean, would you like to explain your thought process?
Well, basically I took 20 divided it by 4 because it takes 4 quarters to make $1, and I got $5, and 1 dime equals 10 cents, which means 10 times would be $1. So the total of 20 quarters and 10 dimes would be $6. If it was 10 quarters and a unspecified number of dimes, it would be $2.50 $2.50. So that would be $6 minus $2.50 divided it by divide that answer by 10. So
Precisely.
basically, yeah.
Yep. Keep going. Yeah.
So basically it would be 600 minus 250 and then divided it by 10, which would give us 35.
Exactly. That's flawless. That's perfect. I guess the way you can visualize what Zion just said is by using a system of equations. But if you don't want to, you don't have to for this problem because it's pretty simple. You just calculate how much money you have from the first half of the statement and then determine how much dimes you have by subtracting $2.5. But another way you could do this is to calculate the number of cents using a system of equations. So you would have 20 times 25 for 25 cents, right? Because a quarter is 25 cents plus 10 times 10. And they say it's equal to 10 times 25. I'm running out of space here. Plus n times 10, right? So if you solve this equation, you would get that n equals 35. And I guess if you fill in the steps, the left side is 600, right? And the right side is 250 plus 10n. So 10n equals 350, so n equals 35. Are there any questions on this one? No?
No.
All right, okay. Let's check out question 8. D, okay, a lot of D's. E, okay. Some conflicting answers here. Are there anyone? Okay, someone else says E. Okay, okay. Kemi says E too. Okay, I think everyone's saying E. Okay, it's Ma Computa says A. Okay. Would you like to explain your thought process? How did you get A?
So 2 times 3 times 4 equals 24. And wait a minute. 1/2 plus 1/3 plus no. Never mind. I didn't mean.
It's okay. Okay, so I guess there's like a couple ways you can solve this, right? So the first way is you can just brute force this, evaluate this, multiply them together. But if you want to be a little lazy and you don't want to add all these fractions together, what you can do is use the distributive property, right? So what you would do is you multiply the first one out, so you get 24. I mean, actually, you don't even do that because all you have to do is 2 times 3 times 4 times 1/2 plus 2 times 3 times 4 times, oh, I don't want that, times 1/3 and 2 times 3 times 4 times 1/4. Then if you do that, you can clearly see that I can just cancel out these factors, right? I can just cancel out the 2, cancel out the 3, cancel out the 4. And then that would give me 3 times 4, which is 12, plus 2 times 4, which is 8, plus 2 times 3, which is 6. So the answer is 26, which is E. So whoever said E was correct. Are there any questions? No? Okay. All right. Congratulations, everyone. You did the first 8 questions. Let's take a look at the next 4. I'll give you about 8 minutes to solve these. Let me know if you have any questions. No, Kemi, class is not over. If you're stuck on any questions, I'm happy to give you a hint. Okay, don't just sit there wasting your time. That's very humorous, Kemi. Okay, everyone, we're gonna go ahead and start. Question 9 about percentages. I think no one really likes percentages. Okay, I got E. Anyone else? No one got an answer except, okay, Kimmy says E. Does anyone else have an answer? Okay, Sean says C. Okay. Jasper says C. Okay, okay. So I think it's pretty split between B and E. So I'm gonna go ahead and explain this question. So the first thing you want to do is cross out the sentence because you don't need it. Right? Because it doesn't matter how many students are in her class because it's asking for a percentage, right? And percentages have nothing to do with how many people are in the classroom, right? It's only a ratio, right? So if Miss Johnson's math class has 10 people, the percentage would be the same. If Miss Johnson's math class had 9,999 people, it would still be the same, right? So that means all you want to do is calculate for the percentage of boys in the entire class, right? And the total number actually doesn't matter because you can see that you have 2 boys for every 2 plus 3 students. So that's 2 boys for every 5 students. So that's 0.4, which is equivalent to 40%. Right, so it's C. I think the people who got E did 2/3, but if you calculate 2/3, that's actually, you're calculating how many boys you have for every 3 girls. But that doesn't really make any sense, right? Because the percentage of boys means how many boys you have for every set group of students, right? So you can't put the number of boys over the number of girls. You have to put the number of boys over the total amount of students to calculate the percentage of boys, right? So I have to do 2/5, which is 40%. Again, the 30 is completely irrelevant. It's just extra information to trick you. All good? Any questions? Nope. Okay. Alrighty. Question 10. What is the number of degrees in the smaller angle between the hour hand and the minute hand? Okay, Kimmy says C. Itzma Kampuda says C. Jasper says D or E. Okay. Would someone like to explain their thought process?
Me,
Go ahead.
because in a clock, when the big hand points at 12, there's also a small hand that points at 7, and then in between there's 6 numbers, I think. Each number between it, I think, because there's 12 numbers, we got to do 12 divided by, 360 divided by 12, which gives us 30 degrees every, turn. So 30 times 60, oh wait, never mind, I don't get it.
Okay, Kimmy, you were on the right track. Okay, you were on the right track. Here, I'm gonna draw a clock real quick. So what Kimmy said earlier about like the degrees, that was 100% correct. Right? Because if you ever looked at a clock before, you know that it has 12 numbers on it. And so 12 spacing. Sorry, this is a really not accurate clock, but I mean, hopefully you get the gist. Yes, thank you for writing the numbers. It's so nice of you. Yeah, I mean, if you look at a clock, right, it has 12 spacings. So since a circle has 360 degrees, each one of these little arcs, which I'm going to highlight here, like this is one of the arcs, each one of these is 30 degrees, right? So that means if you're at 7 o'clock, which is right here, you know that one of the hands are going to point here. I mean, the hour hand is going to point at 7 and the minute hand is going to point at 12, right? So if you look at this configuration, you can see that there's 1, 2, 3, 4, 5 spacings between these two. So that means if you have 5 spacings, you have 5 times 30 degrees, right? And 5 times 30 is 150. So the answer is D. Does this
I
make
got
sense?
confused
Wait, who got
because
confused?
I got confused. I thought it was like 25 degrees. I don't know what I thought.
Oh, I mean, well,
Yeah, because I
you
tried
agree
to
that
do.
there's 12 spacings here, right?
Yeah, I just got it wrong on the calculating every like notch, like from 12 to 1. I'm cause I was calculating it in my head.
It's okay. I mean, another way you can do this is to notice that like 3 spacings is 90 degrees, right? So 1 is 30 degrees. But I mean, that's okay. Are any questions on this question? No? Okay. Problem 11. This is really simple. Just shout out
Is
the
class
answer.
over?
No, Kimmy, it's not.
Oh,
It's over in 2 minutes.
B.
B. Right. The answer is B.
Too
I don't
obvious.
really think, yeah, this is pretty obvious. All you do is like use your geometric senses, right? Okay, question 12. It's a little bit of arithmetic, but shouldn't be too bad. What do we get for this one? E. Okay, I think most people got E. Right, so all you do is you evaluate the fractions, right? In the numerator, you have 2/3. In the denominator, you have 1/2. So when you divide by a fraction, you're really multiplying by its reciprocal, right? So if you're dividing by 1/2, you're multiplying by 2/1. So that gives you 4/3. So the answer is B. Are there any questions? Okay. Since we're running kind of short on time, I'm going to give you these 4 questions, but I'm only going to give you like 5 or 4 minutes to solve it. So you don't have to solve any of these. I mean, you don't have to solve all of these, but I guess just like try the best you can, and I'll see you in 4 minutes.
I can't do anything.
Are they easy? Okay, that's good. That means you're smart. All right, let's start. Problem 13. What did you guys get? E, okay. A, okay. Okay, for the purpose of time, I'm just gonna go over them. I'm not gonna ask for solutions. So looking at this one, since like all of them seem to be decimals, we're just gonna convert this one to decimals too to see if we can match the answer, right? And the way we're gonna do this is hopefully everyone understands that if you do the same thing to the numerator and denominator of a fraction, the fraction is gonna stay the same, right? So what I'm saying is that if you multiply by 0.1 over 0.1, which is basically multiplying by 1, you would get the same fraction, but written in a different way, right? But the value is the same. So that would give you 0.9 over 0.7 times 53. Does this match anything? Oh, look at that. Hey, bam, we're done. Any questions on this one? Okay, I'm seeing a lot of C's. Okay, the reason it's not C is you can simply evaluate it, right? Because if you look at the top, 0.9 is 9 divided by 10, right? But 0.7 is 7 divided by 10. Now that wouldn't be a problem, except that 5.3 is 53 over 10, right? So then if you, like, I guess, rearrange this, you can see that while the top is only divided by 10, the bottom is divided by 100, right? So that's not the same fraction, right? Because again, you have to do the same thing to the top and the bottom. All right, any questions? No? Okay, let's continue. Okay, did anyone get the answer to this one? E. C. C. Okay, I'm seeing some C's and okay. Okay, whenever you have a minimization problem that involves a subtraction, what you want to do is maximize the number you're subtracting and minimize the number you're subtracting from. This way, the difference will be minimized. In other words, since we're subtracting a 2-digit number from a 3-digit number, we want to make the 3-digit number, I guess the top number, as small as possible, right? You want to make it as small as possible. And you want to make the 2-digit number as great as possible. So that means, considering that we only have 5 digits, what I would do is I would let the top one be 245, right? Because that's like as small as you can get, right? And the bottom number, I would put 96 because that's as big as you can get. So subtracting that would give you one, what is that? Is that 149? Right? Yeah, that's 149. So the answer is C. Yep, that is correct. Are there any questions? No? All right, okay, let's blaze through the last question while we still have like 1 minute. All right, what did you guys get for this one? D. Okay, I'm gonna go ahead and solve it. Okay, so basically what you would do is you want to calculate the area of the entire parallelogram first, and then subtract the area of this triangle here, right? And then you do have to know some formulas for this, but basically the area of the entire parallelogram is 8 times 10, and the area of the triangle is 4 times 8 over 2, right? And the 4 is because you have a 6 here, so that means 10 minus 6 gives 4 for here. So you subtract 4 times 8 over 2, so that's 80 minus 16, which gives you 64. So the answer is D. All right, if there are no more questions, you are free to go. And congratulations, you just did 15 questions on the AMC 8.
Bye.
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 Goodbye. Thank you. Good job.